So in this lesson, we are going to be starting Chapter 6 in the Calculus textbook. Chapter 6 is Geometric Vectors, and in today's lesson, we will be looking at 6.1, an Introduction to Vectors. It's going to be pretty straightforward, I hope. A lot of definitions and just getting used to some terms. Okay, well, first things first. What is a geometric vector? A geometric vector is just a representation of a vector. That means you draw a picture, there's a magnitude, and there's a direction. Okay, so an example would be, well, I've got this arrow here at 30 degrees to the horizontal, and the value of this vector is, say, let's call it 30 kilometers per hour. Now, in physics, if you're taking physics, you would have seen that we abandoned the use of the vector symbols for vectors. In calculus, we will start using them again. So if a quantity is a vector, you're going to see the arrow written on top. Okay, so there's a couple of ways of stating vector directions. Well, there's two main ways that we're going to be looking at. The first is called true bearing. Now, true bearing can also go by another name, and it's called azimuth bearing. Now, all this means is if I have to give the direction to a certain vector, so I would be able to communicate to you which way it's facing, I would state that it is a certain number of degrees clockwise measured from north. So if I have north at the top here, okay, and I have, let's say, a vector like this. Let's call this vector v, and it's 30 meters. Well, let's see, what would that angle be? That angle might be something like 120 degrees. Okay, now, a couple of things to keep in mind. The angle for true bearing. First things first, it's always measured from the north. Second, you always have to have 3 digits. Now for 120 degrees, any angle after 100 degrees, you'll always have 3 digits. But even for angles between 0 and 99 degrees, or just under 100 degrees, you need 3 digits. So for example, if I had an angle in the first quadrant, okay, so let's say this is 45 degrees, I have to write it as 045 degrees. So if it's written with 3 spaces, you know that's, well, from the north. Okay, so that's the first way of giving a direction. The second method of giving a direction is called the quadrant bearing. And this one, if you took physics, you will know this one a little bit better, just not by this name. So quadrant bearing means that wherever your vector is pointing, you start from either north or south, and you measure a certain angle east or west. And I think I did it backwards for the video, but you get the idea. So quadrant bearing, let's say I have something like this. Okay, and I know that this angle here is 30 degrees. Okay, so this is vector W. Okay, so vector W is south 30 degrees west. I would not say west 60 degrees south. With the quadrant bearing, you start with either north or south, then you move 0 to, well, not 90 degrees, but 0 to less than 90 degrees, east or west. Okay? So that's really all it is. So we're going to look at some examples now. Okay, example 1. Now this one This one's a little interesting, I'll admit. Okay, so we have 14 centimeters as the vector. That vector is going from point P to point Q. And I know this is 110 degrees. Okay, that, we're not given any compass directions. And from what you saw, both true azimuth bearing and quadrant bearing, they're always measured with some kind of a compass. This doesn't have a compass, and sometimes you're not going to be given a compass. So for something like this, we have to give a system that makes sense. Since we're looking at the vector that is connecting the points P and Q, we call this vector PQ. We have to draw an arrow on top. I like to draw a half arrow. So PQ is equal to 14 centimeters, and direction always give in square brackets. Physics students know this. For everybody else, make sure you know that moving forward. So it's 110 degrees above the horizontal. Now, if you're wondering, well, if I start the horizontal from the other side, I'm going to end up with a different direction. Okay, so when we measure angles, you always start from the positive x-axis and you go counterclockwise. Okay, so that's the case. 3 important elements, or rather 4 important elements to giving this answer. You have to make sure that you've got the vector with the vector symbol on top. You need a value, you need a unit, and you need a good direction. Make sure all of those are there. A lot of people will forget the units. Those are just as important as every other piece. Okay, so this is part A. Part B. Okay. So this is the picture we're given. We have to give an appropriate description. Now I have the north direction, it's going up. I've got my vector u here, and I'm given the magnitude, it's 2.3 kilometers, and I'm given the angle from the north. If you're given the angle from north, that means you're working with true bearing, which is also known as azimuth bearing. Okay, so in this case, we're going to say that the vector u is 2.3 kilometers. Now, okay, this part we're not going to put in square brackets. We'll say at a true bearing, or you can say azimuth bearing, of 135 degrees. And there's 3 digits there, so we're good. Okay, I guess we can actually stick that in square brackets, just so we're consistent. Okay, C. So there's our north. There's our vector v. Let's see, v, this is 9.8 newtons. Again, if you're in physics, I'm going to keep saying physics because this chapter lends itself a lot to physics. 9.8 newtons, and the angle is here 35 degrees. Notice that the angle that we're given is not measured from the north, it's measured from the south. So this is indicating to us that we're not going to use a true bearing description. We're going to be using a quadrant bearing. Okay, so since this is south, that means I am at south and I go 35 degrees towards west. Okay, so my vector v, so 9.8 newtons, square bracket, south, 35 degrees west. Okay, so the way in which you write this, the first compass direction, you start here, you move this many degrees towards the other direction. Okay, hopefully that's okay. All right, example 2. This time we're going to be given the description and we have to draw the picture. So part A, v is equal to 2 kilometers at a bearing of 0 to 0 degrees. Okay, so when I see that 0 to 0 degrees, there's 3 digits there, even though the first one's a 0. That's 20 degrees, but there's a 0. That's telling me it's a true bearing. Okay, so for a true bearing, I measure always from the north. So you have to identify at least one compass direction, and that's usually north. Okay, so 20 degrees, the middle line's 45, so 20 degrees might be something like this. So when I draw my arrow, I have to label this 0 to 0 degrees in the picture too. Now the magnitude is 2 kilometers. You can write that next to it here, and then the actual vector is v. So that would be the answer to part A. Part B. V is equal to 4 kilometers at a bearing of 295 degrees. All right, draw your compass directions. So we've got north, it's a bearing. Now, the word true is not there, but it's still a true bearing, okay? So I'm not given north and south in this many degrees east or west, so I have to assume that I'm starting from the north. It's a bearing, so it's a true bearing. 295 degrees, well, figure out where that is. 0 is at the top, there's 90, there's 180, there's 270, and then you finish up with 360, right? So 295 is 25 degrees more than the 270. So you're 25 degrees of the way into the 90-degree stretch. So you're right here. And we draw our arrow from north, going clockwise, to the vector. So that is 295, that's already 3 digits. This is 4 kilometers, and it's vector V. Done. Okay, let's see, C. U is equal to 40 kilometers per hour at a quadrant bearing of south 70 degrees west. Okay, I know that's a quadrant bearing because I'm given south and north first and then an angle east or west. So, draw my compass directions. Now, south is down here. If I go 70 degrees west, you know the whole gap here is 90 degrees. 70 degrees is almost the whole gap. So I draw the arrow from south, it's 70 degrees towards the west. The vector is u, it's 40 kilometers per hour. So this is a velocity value, 40 kilometers per hour. I think I just wrote it there in the IB physics sense. So if you're wondering what that is, it's 40 kilometers over hours, and this is vector u. Okay, hopefully that's okay. Today's lesson is quite short. It's really straightforward. Okay. Example 3. All right. Now we're going to go back and forth between true bearings and quadrant bearings. So part A, write true bearing (150 degrees) as a quadrant bearing. All right, so first things first, let's draw the true bearing of 150 degrees. So here's my north. True means I start from north and I move clockwise. So clockwise from north, 150 degrees, that's right about here. Okay, so 150 degrees is my angle. Now, giving that as a quadrant bearing, that means I have to start from north or south and then go east or west. Now, I don't want to say north 150 degrees east. Remember that in the definition, the angle has to be between 0 and 90 degrees. You want the smaller angle, right? Why would you make it more difficult? So what you want to do here is say, well, if I start from south, I only have to go 30 degrees towards the east, right? As opposed to starting from north and going 150 degrees, east. So here, we'll say that the quadrant bearing is south 30 degrees east. All right, part B. Write the quadrant bearing north 50 degrees west as a true bearing. Okay, north 50 degrees west, let's sketch that out. So there's north 50 degrees to the west, it's going to be something like this. Now I'm just putting it as 50 because, well, it's not a true bearing, right? I don't need 3 digits. For a true bearing, I have to start from north, go clockwise until I reach that terminal arm, like this. Now that angle is going to be 360 minus 50. So 310 degrees, which is 3 digits, okay? So the true bearing is 310 degrees. The last couple of things in today's lesson is just some definitions and then just a quick application of those. All right, now at the beginning when we started discussing what a geometric vector was, I didn't define what a vector is because, well, we studied vectors in grade 11 and you studied it again in grade 12 when we were studying the IB. So the definition of vector I didn't define again. But let me just quickly mention again what a vector is. A vector is a quantity that has both magnitude and direction. Now, the position of a vector is not as important as how long it is and which way it's pointing. So if you have 2 vectors that are parallel, they're not necessarily the same length. So you might have vector A and vector B. They're 2 different lengths, but they are indeed parallel. They're going in the same direction. Okay, so 2 or more, so 2 plus vectors that are in the same direction. Okay. Equivalent vectors. Okay, so equivalent vectors would be, well, they're the same vector. They have the same magnitude, and they're going in the same direction. Okay, so for all intents and purposes, it's the same. So if I have A, and maybe I have another vector C, they might be at a different position in space, but it's the same length, same direction. So 2 plus vectors that have the same magnitude and direction. And finally, opposite vectors. As you might imagine, opposite just means, well, they're opposite. Same magnitude, opposite directions. So if I have vector A, something that's opposite to it, maybe that's D. Okay? Now, for opposite vectors, I want to make sure it's not a different length. Same length, opposite direction. So 2 plus vectors with the same magnitude but opposite directions. Okay, we'll stop there for today. Okay, tomorrow we're going to carry on with section 6.2.